What's up, simians? Back at it again, another vid. Just made this whole video and then it didn't save, so I'm a little bit aggravated at my iPizzy right now. But we gotta keep rolling. There's no other choice. You feel me? All right, let's go. So first of all, when we're talking about atoms and subatomic particles, you need to know about these parts of the atom. Okay, their charges, their locations, their masses, all that stuff. So real quick, we have protons, neutrons, and electrons. Protons are positive, they have a relative mass of 1. Neutrons are neutral, they have a relative mass of 1. Electrons are negative, and they have a relative mass of 0. Technically 1 over 1840, but really just 0. Protons and neutrons make up the nucleus. Electrons orbit around. Stuff like that. All that about what makes up an atom you should know. So let's do this chart. Okay, magnesium. Magnesium is right here. Okay, so its atomic number is 12. Its atomic mass is 24.3. We'll round that to 24. Okay, so that's what we need. So we have magnesium, which is Mg, atomic number, I already forgot, 12. 12 and 24. So atomic number is 12. The atomic mass is 24. The atomic number is the number of protons. So we have 12. Okay, the atomic number and number of protons in a neutral atom is going to equal the electrons because you need your positive charges to equal your negative charges. Now we just set up here that protons have a relative mass of 1 and neutrons have a relative mass of 1, whereas electrons have a relative mass of 0. So if we're trying to figure out what makes up the atomic mass, the entire mass of the atom, it's going to be protons plus neutrons. Electrons do not factor into that mass because they weigh essentially 0. So we know we have 12 protons. We know we have an atomic mass of 24. So 24 equals 12 plus the number of neutrons. Okay, so pretty simple math. Subtracting 12, you're going to get 12, obviously, right? 12 plus 12 equals 24. All right, if you need extra help figuring out these things, we did this earlier in the year when I first got here. We talked about Ape Man. Ape Man, so the atomic number equals the number of protons equals the number of electrons. Okay, protons and electrons have to be equal to make the atom neutral, and the atomic number is what defines the element. That's why on our periodic table we go start at the atomic number of 1, 2, 3, and so on and so on. We're increasing by 1 proton. Okay, so protons can't change without changing the element. If protons change, the element changes. Okay, now this was mass number minus atomic number. So a mass number minus the number of protons equals the number of neutrons. Okay, that's one way to think about it. I like just saying that atomic mass equals protons plus neutrons. You can do whatever you need to do. Okay, Ge, germanium. Let's find germanium. It's right here. Okay, atomic number of 32, atomic mass of 72.6, aka 73. Okay, 73, and again, I already forgot the atomic number, 32. 32. All right, so that means it has 32 protons. Atomic number always equals protons. It's going to be equal the electrons, and then we need to 73 minus 32 equals 41. So 41 plus 32 equals 73. The two subatomic particles with mass added together equal the atomic mass. Okay, now all we're given is the atomic number, which is 16. That means we know the protons will be 16, and that means we know the neutrons will be 16. So let's find what's 16 in here. Good thing it's organized in order, so we can go right here and see that it is sulfur. Okay, sulfur, S16. The atomic mass of sulfur, 32.06. So just 32. 32 minus 16 is 16. 16 plus 16 equals 32. Our positive charges equal our negative charges because it's neutral, and then the neutrons happen to equal that as well. Okay, I hope I'm going slow enough in this. I already did it once, so I feel like I'm going faster than the first time. I don't know if that's good or bad, but the good news is you guys can pause it or change it however you need to. Okay, atomic number 9. because the protons are 9, which means the electrons are 9. Now we need to find what we're talking about. 9 right here. Fluorine. Fluorine is 9, 18.99 mass, which just means 19. So this is 19. 19 minus 9 is 10. Okay. 19 minus 9 equals 10. And fluorine. Fluorine. F. Okay, now over here all we're given is electrons, but if we know electrons, we know protons. If we know protons, we know atomic number. Let's find what has an atomic number of 18. Argon, right here. Argon, Ar. Okay, the atomic mass of argon, 39.9, which is just 40. 40 minus 18 is going to equal 22. 40 minus 18 equals 22, so 22 plus 18 equals 40, and that's how you figure out your atomic mass. Now, we have atomic mass in neutrons, so 55 minus 30 equals 25. 25 plus 30 equals 55, so we know that's 25, this is 25, this is 25. Okay, so now we just need to find what has an atomic number of 25, and we see that right here, it's manganese. Okay, manganese, Mn. All right, and that's how you fill this out. So your number of protons is your atomic number, which is your number of electrons. To find the atomic mass, you add together protons and neutrons, because these are the only subatomic particles with mass, so you have to add these together. Okay, let's talk about the electromagnetic spectrum. Wavelength is the size of a wave in length, measured crest to crest. So if we have a wave that looks like this, or whatever a wave looks like, and you measure it from the same point, you're going to get your wavelength. You could also measure it from trough to trough. You could measure it from the middle of the wave to the middle of the wave. They should all be the same length, but typically you just go crest to crest. So wavelength is how long a wave is, the length of a wave. And it was squiddly doop whoop in our formulas. Remember those good old days? Wow. Frequency. Frequency is how often a wave passes a certain point. How often a wave passes a point. Okay, so it's waves per unit time. So your frequency, if you set up like a little detector and you had waves going by it, you'd be measuring how many waves pass every second or minute or whatever. You can also think of it like if I said I'm going to measure 3 inches on this piece of paper, how many waves do I have within that 3 inches? The more waves I have, the higher the frequency is. Okay, so that's frequency. Now, how are wavelength and frequency related to energy? Well, we did those equations, you hopefully remember somewhat, where we did the speed of light equals wavelength times frequency. We did Planck's constant. We were relating frequency and energy and wavelength that way. But in general, you just need to know that the higher the frequency, the higher the energy. Okay, higher frequency means higher energy. If a wave's really going crazy, it's going to have higher energy. Now, the higher the wavelength, the longer the wave, the lower the energy, and the lower the frequency. Okay, so if you had a wave, like let's say you have one wave that's like this. That was a very badly drawn wave. I don't even want to deal with that. Okay, if you have a wave that's like, oh, it's not much better. Hold on, one more. A wave like this. Okay, we'll live with that. And then you had a wave that was like this. Okay, obviously the wavelength is way shorter on this one versus this. We can't even see the end of the wave. Okay, here's one crest though. So the wavelength is way higher on this, or longer. But if you were a boat on this little wave, or this big wave, I should say, you'd be nice and relaxed. You'd just be rolling along. You could just chill, kick your feet up on the boat. You know how it goes. Just chilling. If you were a boat on this wave, you'd be freaking out because you'd be like, whoa, whoa, whoa. And it'd be really high energy. Everything would be all over the place, high energy, because the short wavelength, because there's so many waves. This long wavelength is low energy, low frequency. all right? Really hope this video saves because I don't want to do it all again a third time. We'll see. I'll see you guys in the next